Hey guys, Mr. Frazer here coming for you for the 7th day of our e-learning experience. That means it's week 2, day 4, and I can't believe how far that we've come. Now, let's talk some more about decimals. I thought we were talking about fractions. This is decimals. Well, if you knew that decimals and fractions were basically the same thing, then you're on the right track. Decimals, not fractions, but kind of. Fractions and decimals both represent parts of a group or parts of a whole. And I'm going to show you what that's all about today. But here, before we do that, I thought we'd do a little bit of explaining how decimals work and how we use place values. Like I just said, decimals are a lot like fractions because they represent a part of a group or part of a whole. Now, we're going to use multiples of tens in our fractions because that's how they are closely related to decimals. If you see this fraction, we read this fraction as 1/10. 1/10. But we could also write 1/10 as 0.1 because this is our tenths place value. This fraction is 3/10. 3/10. But we can also write it as 0.3 because this is the tenths place value. If we got a little more complicated and we did 5 over 100, we would read that as 5 hundredths or 0.05 because this is the hundredths place value. If you look here, it's a very simple explanation of place value. We know the thousands, the hundreds, the tens, and the ones. But when we add a 0 here and we move to the right of the decimal point instead of the left, we come into the this place values. And we start with the tenths, hundredths, and then thousands. And if you guess that if the numbers are still the same this way as they are going this way, because you notice the pattern, you're right. All you need to do is add a th to the end, and the place values are the same as you move this way, just like if you would move this way. Okay? Next, we're going to do a warm-up activity with comparing equivalent fractions, and then today we're going to make a fruit salad using decimals. See you then. Okay guys, in order to save us a little bit of time, we're going to do these warm-up activities a little bit different from now on. What we're going to do is I'm going to explain it and then I'm going to pause for a second. And you can pause the video and then do the work for yourself. Then I'll explain one answer and then give you the correct answers for the rest of them. Okay? So, today what I want you to do is I want you to match up the equivalent fractions using a line. So what you need to do is you need to find the partner for 3/9. Who is the partner fraction for 3/9? Then move to all of the other fractions and find their partners. A little tip, each fraction only has one partner. I'll give you a second to think about it now. If you need more time, please pause the video. But what I'm going to do is I'm going to start reducing fractions and see if I can find a partner. I noticed here that 3 and 9 are both divisible by 3. If I divide 3 by 3, I get 1. And if I divide 9 by 3, I get 3. So my partner fraction here is 1/3. Now, I cannot simplify 1/2. I cannot simplify 4/7. I can't simplify 5/16 because 5 is a prime and 16 is not a multiple of 5. So I can't do this one. And I can't do this one, but I can reduce the rest of these fractions. 3 and 6 goes down to 1/2. So my partner fraction is here. 6/15 are both divisible by 3, so that would equal 2/5. These are both divisible by 2. 8 divided by 2 is 4. And 14 divided by 2 is 7. So he goes here. That leaves me with 10/32 and 5/16, but I don't see how 32nds and 16ths are related. But again, they're both divisible by 2. 10 divided by 2 is 5. 32 divided by 2 is 16. Matching partner. So those are the answers to your warm-up. Right? Next, we're going to grab some fruit, a cutting surface, and an easy-to-use cutting utensil. No sharp knives because we don't want anybody chopping off any fingers. If you need help from a parent, please do so. All right, see you over at the table. Hey guys, Mr. Frazer here, and today we're going to make a delicious, yummy fruit salad using decimals. So here is our recipe that I want you to try to use if you can. Now, if you don't have an apple or a banana, it doesn't really matter. These two are probably the easiest for us to cut up. So that's why I chose them. So you need 0.7 or 7/10 of a banana, 0.45 or 45 hundredths of an apple, 0.35 or 35 hundredths of a large fruit, 0.90 or 9/10 of a medium fruit, 10.5 or 10 5/10 of a small fruit, or 0.75 or 75 hundredths of a different medium fruit. Now, it doesn't really matter which fruits that you use, but I do want you to try to create these decimals. And I'm going to show you how with the banana and the apple, and maybe give you a hint for the small fruit. And I want you to try these other ones with some help from a parent. Now remember, we want to be careful. We don't want to use a really sharp knife and accidentally cut ourselves. So I'm using what's called a butter knife, which isn't very sharp on one side. So ask your parents what's the best tool to use for this. Maybe with their help, you can use a kitchen knife, but right now I'd like you to use a knife that you might spread butter with, okay? So that's what we're gonna do. And I have a spoon because I'm gonna eat a kiwi with mine. So I'm gonna start with a banana, and it calls for 7/10 of a banana. Now, I need to cut this banana up into 7 or 10 equal parts, because we know that 7/10 also equals 7/10, like this. So that means we need 10 equal parts. I can do this a couple of ways. I can estimate by thinking about how far halfway is, and then when I cut halfway, say I cut here, I would make 5 equal parts here. 1, 2, 3, 4, 5. I could do it that way, or if I wanted to, I could take my ruler and see that my banana is about 20 cm, and I could cut every 2 cm. Either way, it would give me about the same size. If you want to know which chef is best at fractions, take a look at a sushi chef. Those guys are fantastic. So I'm going to go ahead and cut my banana into roughly 10 equal spots. Okay. Now it's not perfect because obviously this one is kind of small at the end, but we want 10 equalish pieces. So now out of my 10, I need to use 7 of them. So 7/10. 1, 2, 3, 4, 5, 6, 7. 3 left over. Now, because it's a fruit salad, and I know that I have 7/10, I can cut these up even smaller. But it's still equal to 1/10. 1/10 1/10, 1/10, 1/10, 1/10, 1/10. So now I still have 7/10 even though my tenths are in smaller parts. Next, I'm going to put these into my bowl and I'm going to grab an apple for 4/500. All right, now I have my apple. I have my 7/10 of a banana split into even smaller pieces, which if I cut them in half, that would mean that my tenths would be multiplied by 2. So then I'd have 20. And if I had 7/10 and now I have 20ths, I would have 14/20 in my bowl. So here's my bananas. Here's my apples. Now, here's the trickiest part about this, is that we need 4/10 and 500. So it would be like if we had 4/10 here and 500. But how in the world are we going to make 100 small pieces out of this, equal parts out of this? Well, let me show you. The first thing I'm going to do is I realize that if I cut the apple in half, that would also equal 5/10. But I only need 4/10. So if I cut this apple in half, being very careful, if I cut this apple in half, now I have 5/10 of this apple. But I only need 4/10. So what I can do is I can cut this into 5 pieces and take one to the side. So now I have 5/10 of an apple. I know I need 4/10 plus 500. So I'm going to take these 4, and these 4 are going to be included. Now I have 1/10 left. Well, if I have 1/10 and I want to change that into hundreds, I need to multiply by 10. So I need to make 10 equal parts out of this. Cut in half, so now I know I need 5. 1, 2, 3, 4, 1. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10/10 of 1/10. So if I was to do this to the whole apple, all pieces, I would end up with 100 pieces of the apple. But now, since I did it to 1/10, I multiplied, I made 10 out of 1, I now have 10/10. But I only need 5/10. So I'm going to take 5 of these, 1, 2, 3, 4, 5, and I'm going to move these away. So now I have my 5/10 here, and I have my 500ths here, and now I have my 4/10 here. So what I'm going to do is I'm just going to cut off the pieces that I don't want to eat, even though they include the apple. And I'm going to chop these into smaller pieces, maybe into tenths, just like I did before. Okay guys, back at the bowl here, you'll notice that I cut the apples into very small parts. In fact, I cut the apple into 10 equal parts, and then I cut each of those 10 parts into 10 equal parts. So I took one apple times 10 would be 10, times 10 again would be 100. Now I have 45 of those. So 45/100ths of an apple, 7/10 of a banana. Now, this next one, or this one here, says 10.5 or 10 5/10 of a small fruit. Now, I'm not actually going to put these in because I couldn't find any small fruits, but I have some cherry tomatoes. And I don't think cherry tomatoes will mix good with bananas and apples, so I'm not saying do that. It'd be better if you had cherries or strawberries or grapes. So I know that I need 10, 2, 4, 6, 8, 10. So these 10 can go into the bowl. And now I need 0.5 or 5/10 of the other one, of one more. But we know that 5/10 can be reduced to a smaller fraction. If we divide the numerator and the denominator by the same number, we can simplify our fraction. So 5 divided by 5 is 1. 10 divided by 5 is 2. Really all I need is 1/2. So this is 10.5, but 0.5 is also equivalent to 1/2. So I could put my 1/2 of the cherry or 1/2 of my cherry tomato into my bowl. And now I have 10.5. Of course, I would probably take this stuff off first. I don't want to eat that. Okay? So that is 3 of our ingredients in. And we still need 2 more. So what I want you to do is I want you to find some other fruit and see, here's a pineapple, I have a kiwi, and see if you can't include the right amount of ingredients into your fruit salad. For your seesaw post today, I want you to take a picture of yourself eating your yummy fruit salad. Banana and apple are delicious. So, do your best to complete this task using decimals for your recipe. All right, guys, I'll see you tomorrow. Bye.